Good morning. My name is Peter Huessy, and on behalf of the Mitchell Institute and the affiliate sponsors, Air Force Association, Reserve Officers Association, and the National Defense Industrial Association, as well as our friends of the Marshall Institute that are giving us the video of this event. I want to thank you for being here on the third of our event, 10 series of seminars on space power to the warfighter. Also want to acknowledge our friends from the Embassy of Austria who are here today, and let you know that our May event will feature Dave Madden, who's the Executive Director of SMC Los Angeles, and we will also have a Navy SEAL who will discuss secure communications, which I think will be very interesting. Our three speakers today will take questions after their remarks. And just to remind you, in our other series on nuclear weapons and missile defense and homeland security, our first event is the 29th of April, where we will have Senator Tester, we have Senator Hoeven, and we may very well also have Senator Heitkamp. And then on May 6th, we have Clark Murdoch of the Center for Security and International Studies. I am very honored today to welcome three of our speakers. Our first speaker will be Lieutenant General John J. Raymond, who is the commander of 14th Air Force, Air Force Space Command and Commander, and is the Joint Functional Component for Space. He leads more than 20,500 personnel at Vandenberg, responsible for providing missile warning, space superiority, space situational awareness, satellite operations, space launch, and range operations. We are also honored to have Colonel John Wagner, who is the commander of the Joint Space Operations Center, or JSpOC at Vandenberg. It is a central node for operational level command and control of the Department of Defense's space assets. We're also honored to have Colonel Erik Bowman, who is the Deputy Commander of the Space Superiority Systems Directorate at the Space and Missile Center in Los Angeles. In this position, he assists with directing and equipping U.S. forces with space control systems to gain, maintain, and exploit space superiority. I want to thank you all, my sponsors, for putting this, letting us put this together by your support. I thank you very much, and I want to thank you for, I know you're stretched thin sometimes, but thank you all for your extraordinary support. And without any further ado, I would like to welcome our first speaker in general on behalf of General Deptula, who could not make it today, and on behalf of our staff here at the Mitchell Institute. I want to thank you for taking the time out of your busy schedule and coming here to tell us what you have to say about space. And thank you, sir, very much. Would you all welcome General Raymond?
Good morning. Morning. It's great to be here. It's wonderful to be here, and I'll tell you, I think I've worked for about half the people that are in this room. And you probably all came wondering what, how did that guy make it there? But it is my honor to be here this morning. Yesterday, I had the opportunity to testify to the House Armed Services Committee. That's the first time I had the privilege of doing that, and it also was a great event. But I'll tell you, there's a lot going on in the space business, and I have been in the space business for a large portion of my career, almost all of my career, and we've all heard about how the environment has changed, and it really wasn't until just a couple months ago when I took command that it hit me just how much transformation has occurred in the space domain. And I'm going to kind of set the stage for this SSA conversation, which I've been asked to have, and then a little bit about Space C2 as well, with just what I have seen in the couple months that I've been back. Please pass along my regards to General Deptula. I had the privilege of working for him a few years ago. He's a extremely bright guy. I taught him everything he knows about space, but let him know that. There's a funny story there. I won't go in there this morning, but let me begin by introducing our lineup today. So with me this morning is, as you heard, was Colonel John Wagner. He goes by Wags. He's the director, the commander of the 614th AOC and the director of the JSpOC. He's in charge of running the C2 facility, if you will, or ops center for all of space from the JFTC space side of the house. Also joining us is Colonel Erik Bowman, who's the Deputy Director for the Space Superiority Directorate from the Space and Missile Systems Center. I know you all know, I'm speaking to a friendly crowd here, but that's Air Force Space Command's acquisition arm. Again, this morning I'm going to set the stage talking a little bit about space situational awareness, and then I'm going to turn it over to Colonel Wagner, and he's going to walk you through about 3 or 4 vignettes to bring my words to life and give you some examples of what we've been seeing over the last just over the last couple months. Again, I have been completely amazed at the magnitude. I've been in the space surveillance business before. I've commanded the 21st Space Wing, which is the space surveillance wing focused on space surveillance. I've commanded a space surveillance squadron earlier in my career in England. But and we have all heard of the congested, contested, and competitive language. I'm looking to Bob Butterworth. He's a longtime mentor, and I appreciate you being here. But we've all heard of those words, and I mean, I've used those words in speeches all the time. I mean, that's kind of the standard thing that but I know I didn't, and I don't think people in this room probably realize just what that means in what we're seeing on a day-to-day basis. And that's what I'll try to do today. So space situational awareness is the foundation for our mission success. I can't do my job if I don't have space situational awareness. Without it, our units and operators can't do their job. SSA is a really tough business, and it's getting tougher each day. The number of objects in space are growing, are increasing. The size of the satellites are decreasing. The number of spacefaring nations continues to grow, and the capabilities of individual satellites increase as well. All of this means that more groups are doing more things with more objects in space, and also means a potential adversary is more likely to develop capabilities to deny both our use of space and the operational and strategic advantage that our nation enjoys because of our space capabilities. So the way I think about space situational awareness is that to have true awareness of the domain, you have to have an understanding of what's coming into the domain, how it operates in the domain, and then how it exits the domain. And kind of using that as a framework, I thought I'd give you a feel for just how congested, contested, and competitive this domain really is. It's something, again, that was eye-opening to me. So entering the domain, and I'm going to tell you these statistics are like 3 days old. I left town at Vandenberg on Wednesday evening, so it was kind of noon on Wednesday when we put the final stamp on these. There have been some changes, and those that I know I'll highlight in my remarks, but I'm probably 1 or 2 or 3 off on each one of these because that's just how volatile the domain has been. But since January 31st, which is the day that I took command, we have detected 145 ballistic missile launches and provided warning of those launches to joint commanders all over the world, telling them where the launches were coming from, the type of missile launches, and where they were going, and assisting in determining whether those launches pose a threat to our forces, our allies, or to the United States. We also planned to detected, tracked, and identified and documented 14 space launches. I have to up that number to 16 because yesterday there was 2. Yesterday we had a successful DMSP launch out of Vandenberg, and then there's another launch. It wasn't a U.S. launch, but so we're up to 16 as of yesterday afternoon, and may be more today. What is noteworthy, however, is the number of multiple payload launches that have taken place. As technology matures and satellites are becoming smaller and less expensive, the dynamic has changed. So I brought a couple show and tell things here. And I know that a lot of you in this room know this, but some may not. This is a CubeSat, and I'll pass this around. Like the CubeSat, it's making our mission of space situational awareness even more demanding. To emphasize this challenge, in all of 2012, the entire year, 72 new satellites were placed into orbit. In just one 7-day period in 2013, 78 new satellites were launched, or placed into orbit on multiple payload launches, CubeSat size. That makes it a little bit more difficult to track. We can track them, but they're smaller and a little bit more difficult to track. More recently, in February of this year, the International Space Station deployed 33 of these CubeSats just a couple weeks ago from the International Space Station. This month, SpaceX Falcon 9 ISS cargo launch resupply mission is programmed to deploy 5 additional CubeSats and 104 chipsats. For those that may not know what a chipsat is, that's a chipsat. And we'll pass that around on this table. But that we can't track, so it's too small. 104 of those things in one launch. And it's a university student from Cornell project that's going to put that up on an EOE, and it's on a Falcon 9, and it's an experiment just to make sure you can have connectivity with chipsats from the ground. Again, we're not able to track those. In orbit, we track about 23,000 objects in space. 1,100 of those objects are satellites, active satellites. About 75% of those 1,100 are maneuverable. Estimates are that there's about 500,000 other objects that we can't track. They're too small to track, like the chipsats or other pieces of debris. Although small, they can be deadly, because if you take a small object, even that size, and make it fly at 17,500 miles an hour and runs into something else going 17,500 miles an hour, it could be pretty destructive. Since the 31st of January, again, we have processed 25.2 million observations, 420,000 a day of things in space, and we have issued 200,000 warning notifications of potential conjunction in space. 200,000 since the 31st of January to global spacecraft owners in 130 different countries. We're doing this for the world. We share our space surveillance data worldwide on spacetrack.org, www.spacetrack.org. Sign up for an account, and you can get the information for yourself at your fingertips, most all the space surveillance data that we have. And we do that because it's also in our best interest to extend that space flight safety, if you will, to the space domain, because we have to operate there as well. And we have seen examples in the past where there, for example, the Chinese ASAT in 2007, which littered the orbit with debris, and now we are, a lot of what I'm going to talk about here over the next couple minutes of doing conjunctions and maneuvering to avoid conjunction is based on that event. We've entered into 41 SSA sharing agreements, Space Situational Awareness sharing agreements, with commercial companies, and 5 sharing agreements with other nations to provide more routine services. So on spacetrack.org, we put information out on the catalog, if you will. If you sign an agreement with us, we will give additional services like launch analysis to give you windows on when to launch and when not to launch based on COLAs. We give you a more routine conjunction assessment. If we ever determine that there's a potential conjunction, whether you have an agreement or not, we'll let everybody know on an emergency basis, again, to protect the space domain for all to use. We're also in Stratcom is doing this, but we're also in coordination with at least a dozen other more countries right now to sign additional space surveillance agreements. Since the 31st of January, I've got to up this number. It was 21. I know at least now it's 22 satellites have maneuvered. I talked yesterday. Last week we maneuvered the International Space Station for just the 16th time. Yesterday we did it for the 17th time, so 2 times in a matter of a week. 21 satellites maneuvered to ensure that we don't have another catastrophic event like the one that occurred in 2009 when the defunct Russian satellite ran into an Iridium satellite. And that event caused 2,500 pieces of debris. I talked about NASA moving it for the 16th time. Yesterday was the 17th time. That's noteworthy. However, what's even more noteworthy is there was another example 2 weeks ago where 2 satellites in low Earth orbit where we had a potential conjunction, had an overall missed distance of less than a kilometer. Again, 17,500 miles an hour going each way, and neither one of them had the ability to maneuver, which is one of those you sit back and hold your breath. We assessed and characterized and mitigated 23,000 SATCOM interference events. 23 SATCOM interference events and restored communications. We've published 90 intelligence summaries that informed our space operators about the threat, because we are no longer operating in a benign space environment. Today we are faced with a contested environment where the counter-space threat is increasing as our potential adversaries pursue disruptive and destructive capabilities, everything from jamming, reversible jamming, all the way up through destructive anti-satellite weapons. Exiting the domain. In the military, we're really big at hails and farewells. We've unfortunately done more hails than we've done farewells. Coming out of the domain, we've projected 2 and processed 2 deorbits and 7 decayed reentries. We track all that as well and provide warning of those events as well. Again, we provide SSA data not just to our friends and our allies, but to all spacefaring nations and space companies, because we are committed first and foremost to a safe and peaceful use of space by and for all. No other nation, no other organization except the Air Force and the Department of Defense have the resources and skill to do this job for all objects throughout the space domain. Admiral Haney, the commander of United States Strategic Command, has provided me with 3 operational objectives. They are: 1, provide timely and accurate warning and assessment; 2, support national users and joint and coalition forces; and 3, protect and defend our space capabilities and prepare for contingency operations. As previously mentioned, maintaining space situational awareness is absolutely critical to meeting these objectives. Can't do my job without it. The other must-have is the ability to command and control our space forces. Our current C2 system is called SPADOC, the Space Defense Operations Center. It was built in the late 80s. It was designed for a different era. It wasn't a contested or as congested space domain. It's at the edge of its capacity. It is reactive in nature. It does not support fusing of information or collaborative operations or testing of hypotheses in order to fully develop response options. We are currently transitioning to the Joint Space Operations Mission System, or JMS for short. JMS will significantly enhance our ability to understand the space domain with an improved integrated operating picture and increased ability to respond to a dynamic space environment. The JMS architecture will allow us to aggregate and rapidly process data into actionable information for senior decision makers. JMS is being delivered incrementally. With each increment, we enhance our ability to understand the space domain. Increment 1 is already up and running on the operations floor at the JSpOC and is already providing us significant operational advantage. Let me couch it to you in this way. I talked about SPADOC being our C2 system. What Increment 1 does is put a visualization tool on SPADOC. So rather than, when I went on the ops floor, when I first got here, I went to a young operator sitting at the SPADOC terminal, and I asked him, there was a multi-payload launch earlier, about a week before, and I asked him, hey, where are those satellites? And he goes into SPADOC and, types www, where are those satellites? And a spreadsheet comes out with a bunch of numbers. And so, well, that's great, but where are the satellites? He said, sir, well, it's, inclination this and this and this, and I'm like, not good enough. Let's pull it up on JMS. Pull it up on JMS, and there's real-time picture of where the satellites are orbiting around the globe. So that's where we need to get to, because we're going to respond to the events that we're going to may have to respond to in the future. You can't do that. At least this guy can't do that looking at spreadsheets and numbers. You got to have a much more interactive. And that's what Increment 1 does. It's already working well. Increment 2 then replaces the search engine, gets us off of SPADOC, and we've already taken the first what we call service pack delivery of Increment 2. We're doing developmental testing of that as we speak, and we expect that to be done in 2016. And again, at that point, we will have weaned ourselves off of SPADOC and have a more responsive, predictive system able to take in more data from a whole host of sensors and be able to integrate it. Increment 3 then, as I've been pushing on our team, JMS has got to be bigger than SSA. JMS has to be a C2 system that can do everything we need to do in space. And Increment 3 then provides us those apps like on an iPhone that gets us to true C2 of the space domain, really focusing on the warning and assessment mission and the protect and defend mission. It isn't all about systems, however. Much of our processes and tactics are reflective of the limited systems capability that we had to work with. We are in parallel looking at how we can modify our procedures to better inform future deliveries of JMS and increase our proficiency in the capability that JMS promises to deliver. Again, I really appreciate the opportunity to be here. It's great to see a lot of old friends and familiar faces. I wouldn't be here today without a majority of the folks that are in this room, so I thank you very much for your service. I thank you for all that we have done together over the last groups of years, and I look forward to continuing to work with you in the future as we go forward. We have a lot of important work to do. I'll tell you, having been a space operator and used the words contested, congested, and competitive, I didn't get it until the last 2 months. And if you look at what Colonel Wagner and his team have to do each and every day to maintain space situational awareness, to maintain the sanctity, if you will, of our ability to operate and to get those capabilities and the operational and strategic level benefits that we get from space. It's a pretty heroic task. And so with that, what I'm going to do is turn it over to Colonel Wagner. And as I went through some of these statistics, I've called out a couple of events. Colonel Wagner is now going to give you that from kind of the JSpOC Ops 4 perspective, and what do they actually do to process those events and give you a little bit better understanding of what they do each and every day. After that, Colonel Bowman will come up and talk about his SSA portfolio and tell you where we're going in the future. I'm very encouraged by the work that I'm seeing and the capabilities that we're delivering to certain parts of the world, and in focusing on certain orbital regimes to help fill some gaps that we have there as well. And also, obviously, clearly, as I've talked about, very encouraged by the work that's being done, that they're doing on our behalf on JMS. So that's the rest of the morning. After those two gentlemen talk, we'll open it up for questions and answer anything you may have to ask.
Thank you, John.
You should try carrying one of these things to an airport. That's why you have an aide.
Thank you, sir. I had the pleasure of carrying this yesterday through the airport, so I'll see if I have to carry it back to help the aide out a little bit. But thank you, sir, and thank you for the Mitchell Institute and for everybody here, too. I see a lot of familiar faces in here, too, that I have worked for in the past, so thank you for your mentorship that helped me get to where I am today. I've got the best job in the Air Force. I mean, I really do. Working for General Raymond and providing him the ability to command and control 54 JFCC space units around the globe. To whether it's Army JTAGs or whether it's a space company or whether it's a space warning squadron or a space operations squadron. I mean, tying all those units together from strategy to task is really what we do at the JSpOC. Yes, we do SSA. SSA is job one, but there's also the guidance that we need to get from General Raymond, the planning, the tasking, the executing, and then replan, retask, and reassess. One of the things that the Air Force does really well is command and control. And we've learned that through really since the first Desert Storm, and before that through something we call Air Operations Centers. And maturing the AOC concept is really what the Air Force has done over the last 20 years. We're leveraging that success and that experience in the JSpOC. So as the 14th Air Force Commander, he's got a 614th AOC, kind of like the 9th Air Force Commander has a 609th AOC. I'm apportioned as a commander of 614th AOC to STRATCOM, and that forms the JSpOC. So you add some joint bodies on top of the Air Force bodies that the Air Force provides, and that composes, like the KAOC at Al-Udeid, for example, we're the JSpOC. So the director of the JSpOC is my operational duty title, if you will, providing the command and control aspect for all space forces. So General Raymond has that capability to reach out that they just talked about. I'm going to walk through just a few events, and as General Raymond talked about, we look at getting after Admiral Haney's objectives. We look at everything from entering the space environment, so launch, and it's not just about the launch, right? So I have a position on the floor called the Space Operations Mission Commander, and I talk to him every morning. And when he says, "Hey, sir, we just had a launch," I say two words: "So what?" The so what of that is, so what is, where's the payload? If it is a payload, then I ask the so what again. What's at risk? Do we have anything at risk? What's it doing? What's it looking at? And what's the mission? If it is a domestic mission, obviously we want to maintain custody. If it's non-domestic, we need to know where it is, and again, if it poses any risk to our assets. So launches are the most visible. And yesterday we had a launch out of Vandenberg. So for those of you who can see it on YouTube, good shot on YouTube. So it's an Atlas V DMSP launch. A great, beautiful launch. I was in LA getting the plane here, so I missed it. So YouTube has it, so fortunately. And we're tracking, obviously, the spacecraft, the rocket body, and two pieces of debris. That's just one. So one launch, we're tracking four objects. As General Raymond mentioned, it's not just the launches anymore, it's the number of things on each launch. So, for example, in February 27th, we talked about our SSA partnerships that we're having and expanded sharing agreements. We've got an expanded sharing agreement with Japan. And so we cooperated on the Tanegashima launch, the 27th of February. That carried the $3.2 billion, it's called the GPM, the Global Precipitation Measurement Satellite. But it also carried 7 other smaller payloads. So you have a primary, this is the trend that we're seeing. You have a primary and you have a number of smaller payloads, and as General Raymond showed you, I don't know where the CubeSat is now, but it's being passed around. That's kind of what we're seeing. And so gaining custody, we call it gaining custody. It's not like putting those satellites in jail. We just want to make sure we know where they are, kind of like where you want to, I want to know where my kids are when they enter the store. I want to make sure I have at least some awareness of where they are and where they're going, and if they're at risk of, buying anything they shouldn't, or at risk of running into people. So that's kind of what we talk about when I talk about gaining custody, gaining and maintaining custody of all objects in orbit. That's just the trend that we're seeing. As General Raymond highlighted, really in November, there was a series of launches, as some of you may have worked on the one from Wallops Island with 28 payloads on that one mission. So again, 28 to now, as we see with the ChipSats, hundreds of things that we're tracking that enter the domain. So those are the cooperative launches. We talked about the Tanegashima launch. We talked about the Wallops launch. There's also the non-cooperative launches. And it's important for us that we need to distinguish missile launches from space launches, and provide that missile warning from space warning. It's all about quickly and accurately characterizing risk. We've got to characterize risk as fast as possible and communicate that risk to leadership as well as to the units to make sure that they can react. I talked about the AOC and the Air Force. One of the things we learned back from Colonel Boyd is observe, orient, decide, and act. For those of us in the Air Force, we remember that, or General Jumper, when we matured the AOC, it's find, fix, target, track, engage, assess. So that's really what we try to do as fast as possible. So command and control, for you engineers in the room, is a delta T problem. I want to shrink delta T as much as possible. So it's a time to observe, orient, decide, so we can act. So if it is, we need to execute the order to maneuver a satellite from, whether it's an anti-satellite or an object that's coming into harm's way, we want to make sure we do that before contact, or frustrate an adversary's targeting solution or something, but be able to protect those $3.2 billion assets. It's not just about the money. It's not just about the asset on orbit. It's about what those things provide our joint forces around the world, a lot of them in harm's way. So it's why we wear the uniform, and it's about the soldiers, sailors, Navy, our airmen and Marines that are off, fighting our wars, if you will. And engaged in conflict, and it's about supporting the President, supporting State Department, all those that need access to space systems worldwide. It's making sure the viability of those continues. So I talked about launch. As we talk about in space, SSA, our job one. I know General Shelton said that here in February as well. And it's planning, tasking, optimizing sensors. We've got 27 sensors on the ground around the world, so ground-based radars and opticals that we make sure we optimize for maintenance, so we need to weaponeer, if you will, not that we need to understand when things are launching so we can make sure we can optimize sensors to detect, track not only the launch but all the smaller objects that are coming off as well. And then we're in the era of trying to integrate non-traditional sensors as well. So our sensors, and I know Colonel Bowman's going to talk about sensors here when he talks a little bit. Our sensors are Cold War-based CONUS sensors, largely missile warning radars that are dual purpose. So we get a lot out of those sensors, and I know that we're trying to develop TTPs, tactics, techniques, and procedures to try to squeeze as much out of those as possible for detecting the objects that General Raymond highlighted to you. But more is needed. So better sensors, better computing power, that's hopefully where we're headed in the future, and we're trying to make sure that we give the requirements to the acquisition community to go do that. I know he's going to talk about that in a minute. But we talked about the International Space Station a little bit. I know John Raymond mentioned it. 2 weeks ago, they maneuvered for the 16th time. Just yesterday, The ISS maneuvered for the 17th time, as he mentioned. And the ironic thing, it was due to a large piece of, we call it debris, but it's a rocket body part from an Ariane 5. So it was an Ariane 5. For those of you who know the Ariane 5, it's called a SILDA payload adapter. And that payload adapter, it's about a 16-meter component that's used to put lots of small payloads in orbit, so like an additional payload ring. So, and it was the piece of debris that ISS maneuvered. It was a 388-meter miss distance, putting the probability of collision to the space station at 4 in 1,000. So it pretty close. You know, we provided that data. Now, in addition to the operators I have on my floor, there are also NASA Johnson and NASA Goddard contractors on the floor as well. So we work a very tight partnership with NASA for space situational awareness, particularly when it comes to protecting humans on orbit. So very good, very tight partnership. And then let's talk about what comes out of the domain. So you're all familiar with the Soyuz. The shuttle obviously is now in museums. We've got one here, I think, out at Dulles. But the Soyuz, the last time it came in was 11 March with humans on board. It came back 11 February, so about every month or so we're deorbiting something from the station that takes it up. It's important that we obviously track where these things are and where they're going. But those are the things that make the news. What doesn't make the news is about 2 deorbits a week, not deorbits, but reentries a week. And the difference is deorbit, obviously a purposeful, I'm going to, you know, it's energy required to bring the astronauts and cosmonauts back. But there's stuff that comes out of orbit every week. So 2 or 3 times per week, we're tracking those things and trying to get resolution on where it's coming in and when. So again, that risk detection and prevention. Obviously the notifications have to happen as well. Because we don't want anybody to interpret that as a hostile act. If you see a reentry, it's you know, associated. We want to make sure that our notification passes to the NMCC, Department of State, NASA, FEMA, STRATCOM, of course, and I know that they pass that data to the Russians as well, just so we're all as part of the agreement. I think it was in 1971 for nuclear weapons. So we want to make sure that the world has that situational awareness. So it's what goes into the domain, what's in the domain, what's coming out of the domain, but it's also, as General Raymond talked about, EMI reports. It's about the signals that come back and forth to make sure that these, particularly our payloads, aren't just space junk. Because if you've got a $3 billion asset on orbit, it's about the mission of what that provides to our joint forces worldwide. So we ensure the viability of that as well. So if there is EMI, we try to mitigate the electromagnetic interference. I've got space weather folks on the floor. That's why they're on the floor to say, is it a natural environment? So is it a solar flare? Is it a proton flux that may be causing the EMI? Or is it man-made? And if it's man-made, is it intentional or is it unintentional? How can we resolve it to make sure we can have the viability of the mission? And then all of that together we lead to our joint force support. So it is support to combatant commanders worldwide, as well as to the commander of STRATCOM in the space joint operating area. So my point to you is it's not just about space, it's about what space provides worldwide, and some delicate integration and it's typically simultaneously to combatant commanders worldwide. That happens traditionally through the space coordinating authorities and the staff officer that you know called the Director of Space Forces, so helps us coordinate. We coordinate, that's the great thing about the AOC. We coordinate directly with other AOCs worldwide from an intel, from of targeting, from an operations perspective. So there's a good synergy and a synchronization that's happening with reach back from other AOCs to the space AOC and then pushing data out forward. Whether it is, you know, flight following a carrier strike group through the Strait of Hormuz, for one example, and looking at EMI or what have you around the world. The space support requests come in, probably two a week, and we're busily answering those to whether it's optimizing GPS, whether it's minimizing electromagnetic interference, whether it's detecting, obviously detecting missiles and any special requests that come in from combatant commands around the world. The point is, we've got to make sure space continues to enhance our joint and coalition forces worldwide. Our work never stops. We never sleep. We're up 24/7, 365. So as I talked about the AOCs, typically, a lot of them are in caretaker status until a conflict erupts, and then they stand up and then go full force. Again, I talked about the reach back and the capabilities we provide. It doesn't stop. So as General Raymond mentioned, it's getting busier. It's an exciting time, and I am just fortunate that, again, I've got the best job in the Air Force. I'm going to turn it over here to Erik Bowman to talk a little bit more about programs. But from tracking, planning, procedures, and intelligence, detection, and warning, we're trying to get better, faster, because we all depend on these assets, and we can't wait until we can have better equipment and other things to do that. So I'll turn it over to Erik Bowman to take us through.
Thanks, Colonel Wagner. For those of you who don't know me, I'm Colonel Erik Bowman. I'm the Deputy Director at the Space Superiority Systems Directorate. Many of you might know Colonel Baird. He really wishes he could be here today, but he had to send me, as the technical term would be, the BRU, as the Baird Replacement Unit. So hopefully I'll be able to do justice to him while we're here today. At the Space Superiority Systems Directorate, our job is to build and deliver systems to General Raymond, to Colonel Wagner, and the rest of the JSpOC that helps them do their job better. One of the themes you've heard right now is that we want to move from a more reactive, passive catalog maintenance concept of operations to something that supports a more of a battle management, command control, communication capability, something that's more predictive, more tactical, and more intelligence-driven, that lets us respond better to what's going on in space. In other words, we want to build a system that not just reports what's happened up in space, but predicts predicts it in time to allow us to develop a course of action to respond to those to protect their space assets. Now, one of the things that Colonel Wagner talked about was part of his job is he needs to have quick and accurate risk assessments. So really, if I'm looking at what the primary shift from catalog maintenance to battle management, command control, and communications is, it comes down to two parameters: accuracy and timeliness. Now, so what we're trying to do with most of the things at the Space Superiority Directorate is we're trying to build systems that move us to get really focused on that accuracy and timeliness. But before I talk about the specific systems, I want to give you a little more context as why those are so important. First, I'll talk about accuracy. Accuracy is more than knowing exactly where the spot is in space, although that's a huge piece of it. Accuracy also means knowing with a high confidence that you know exactly what's going on up in space. If you're going to want to respond to an event in space, you don't want to be responding to false alarms. And so let me give you some examples for this. Let's look at the conjunction analysis, the conjunction assessment or collision analysis. If you think the satellite's here and you think that it's going to be in your way and you're going to maneuver, if it's a false alarm, the satellite could actually be here and you could actually maneuver into the satellite instead of away from it if you have the wrong information. From an environmental standpoint, if something happens, your spacecraft stops communicating with the ground. There could be a variety of reasons for that. If you mistakenly assume the spacecraft is under attack, as opposed to it's just a natural malfunction of the spacecraft or a solar flare hit it or something like that, obviously if you acted on the wrong information, it could have serious national consequences. So we want to make sure we get the information right. Timeliness, on a similar note, timeliness is more than just doing things faster. It's getting the information to the decision makers in time for them to accurately assess the situation. It's giving them time to develop potential responses for it, and it's getting them that information in time to actually execute those responses. It's a much longer timeline than you might think. So again, I'll look at where timeliness comes into play. Even if I know a collision is occurring, if I don't get that information in time to actually move the spacecraft, it's no good to anyone. If I get warning of a solar flare coming, it does no good to anyone if I get that after I don't get enough time to actually safe the spacecraft and prepare it for that particular action. So when we look at what we're doing, we'll start first of how can we make things faster. One of the things is just to do what we do today, only faster, and that's where JMS Increment 2 comes into play. One of the things we talked about was the collision assessment. Right now, today we do run a conjunction assessment for the 1,100 active satellites against the 23,000 objects out there, 72 hours in advance, and we can do this about once a day. And the reason why is because we've given the JSpOC the latest, the 1980s era technology. Okay, the stuff just isn't quite as fast as we might like to have.
We're making it work, though.
We are making it work, but we want to do a little better than that. So it's very computation intensive, and that's why it's once a day. And once a day works well if you're in a benign environment up in space. But as you move to a more contested, congested, competitive environment, this becomes more of an issue. If you have a launch that's coming off the ground, 24 hours in advance might not be sufficient. You might only have an hour to get out of the way, or a spacecraft maneuvering. You might not have 24 hours. You want to do it faster, and that's where JMS Increment 2 comes into play. We're upgrading the computing architecture with JMS Increment 2 to go to a more high-performance scaled computing system, and we should be able to get this conjunction assessment in near real time once JMS Increment 2 comes online. This means that we will be able to get those responses hopefully in time to do it. We're taking what we do today, exactly the same processes, but we're really trying to shrink the OODA loop that Colonel Wagner described down to a much smaller time frame to enable us to respond. Now, another thing that we have to do for both accuracy and timeliness is, besides making things faster, is sensor coverage or getting more data sources. Really, the more sensors that are looking, or more data more things are being observed at the same thing at the same time, the more accurate it can be. You always, like a newspaper reporter, usually they'll get an initial report and they'll need another source to confirm it to make sure it's accurate. That's kind of the same thing we want to do with sensors. And that means putting them in different places. Right now, most of them are in the continental United States. Now we want to spread them across the globe to do things a little more. So another thing the more sensors do is, the more things are viewing it, the sooner you can detect something. If they're all around the globe, it doesn't take a whole orbit to detect something. You can detect it in a much sooner time frame. So we're putting a couple things out there. One is the space fence you might have heard of. That's going to be hitting initial operational capability in 2019. We're putting that out at the Kwajalein Atoll in the Western Pacific. And what the space fence is going to do is it's going to let us see smaller objects. It's going to let them track them more accurately. It's going to see more objects. And because of its location, it's going to see things in the Eastern Hemisphere much more quickly than we're able to see today. We're also moving the C-band radar from Antigua. It used to be supporting space launches out on the Eastern Range. We're taking that radar and we're moving it to Australia. In fact, it's disassembled right now. We've been taking it apart. It hasn't get shipped to Australia yet, but it's already in the process of being taken apart. We expect that to be operational in the 2016 timeframe. It's our pathfinder for working with Australia to get additional data. So we're starting to work with more international partnerships as well there. In addition, another Australian thing is the Space Surveillance Telescope. It's an experimental telescope sitting in New Mexico right now. We're going to take that and move it to Australia as well in the 2017 timeframe. And that's going to be looking up in the deep space realm, up in the geostationary orbit where all the communication satellites are. That should give us a dramatically improved search capability up in space, as well as, again, far more sensitivity. Another system that was just recently announced was the Geosynchronous Space Situational Awareness Program. This is going to be another system that is space-based and provides a unique vantage point from its home in the geostationary orbit to look at things, to augment what we currently have right now, which is a space surveillance telescope, which is in low Earth orbit looking up. In addition, in the 2016 timeframe, we're going to begin the work on the SBSS follow-on program to keep that particular capability alive. And what the space-based systems do, the ground-based systems don't, is they give you 24/7 all-weather coverage in to let you really track stuff up there. Now, beyond that, a recent change has been Air Force Space Command has recently given responsibility from Air Force Material Command and moved over to us under SY of all the existing legacy ground-based radars and optic systems, the dedicated ones, with the intent of letting us start to operate space situational awareness as an enterprise, so we can move from building each sensor individually to building an integrated network that can greater enhance space situational awareness. Now, all these new sensors are going to give us better accuracy and better timeliness, but they really still don't do the job unless you can actually get the data to the folks at the JSpOC in a form they can use. SPADOC cannot ingest this data right now, but JMS can. And when we get to JMS Increment 3, we're really going to start to, combined with a program called the Net-Centric Services and Data Sources Program, we're going to really start to see we're going to start that shift from catalog maintenance to a true battle management type of perspective. Whether the threat's going to be collisions up in space, launches, EMI events, electromagnetic interference events, or kinetic attack, we're going to be trying to grab additional sources to bring it in. So we're not going to be just simply the radars and telescopes. We're going to bring in non-traditional data sources. Okay, we're going to start grabbing some things from the intelligence community that can help give us indications and warnings. So besides trying to shrink the timelines that it takes to process things, we want to look we want to try and get things before they happen, get those indications and warning to tell us, hey, this thing's coming up. Maybe you want to move your sensors and look at them ahead of time as opposed to merely responding to them. Some of those types of things should be there. Additional processing algorithms as well to give us tip-offs as to things that might be going on. We're going to bringing in the electromagnetic interference as well as the space track information into this user-defined operational picture, that 3D view that General Raymond discussed that lets him visualize everything. We're going to start bringing that into the same interface so the JSpOC operators can see that more intuitively. We're going to start bringing in things like overhead persistent infrared data from systems like the Defense Support Program and the Space-Based Infrared System, or SBIRS, to again get indications more quickly into the system. And last but not least, we're going to have modeling and simulation tools that will allow the JSpOC to do some what-if analysis, look through what kinds of courses of action they can develop to do it. And to the industry folks in the crowd, I'll also mention that when JMS Synchro 3 comes online, we're also going to have something we're calling the Arcade. It's actually an acronym, and don't ask me what it stands for because I can't remember exactly what it is. But the idea is it's going to be an environment where industry can come and kind of play with the system and see what tools you might be able to develop that can help us to do things better to support the warfighter in this environment. So the combination of all of these things coming together, again, the focus is improving accuracy and improving timeliness. And if we can get those done with the future upgrades of JMS and the rest of the sensor programs, hopefully we'll move to that battle management, command, control, and communication system to really protect our assets in space. And with that, that concludes my part. And I think, unless, General Raymond, do you have any comments, or just open up for questions?
Well, since I have the mic, I guess that gives me the floor. My name's Erik Thomas with Lockheed Martin. Thank you, gentlemen. Really excellent comments. We do appreciate it. We don't get enough of this kind of insight here in Washington, so it's very, very valuable. That's my speech. Sorry, Peter. But the question is, to what extent are you going to be able to ingest data from sensors at the Missile Defense Agency or other agencies, when I'm thinking Aegis or THAAD radars or things like that, that are obviously deployed globally or will be more extensively deployed globally in the future?
It's a great question. And everywhere I go, in fact, just today, I was, at breakfast, and I said, we've got all these sensors. We've got to be able to take all those sensors, the traditional space surveillance sensors and non-traditional space situation, take that information, fuse them together to get a better understanding. So the JMS system will allow us to do that, to take those cooperative sensors, input it, fuse the data together, and then spit out a solution at the end. And it being architected in a way that we can also take foreign sensors and get them into it as well. Great question.
Greg Orndorff, SGT. I'll hitchhike and say thanks for being here. This is good insight. How's for this mission area, how's the budget outlook? Are you guys going to be able to grow, or is it going to stay level?
Budgets are tight. I'll tell you, the way I would answer that question is, I think there's a realization that SSA is foundational business, and if you don't have SSA, you really can't do anything. So, as I would look to prioritize resources, I would think this would prioritize pretty high in the resources that we have. That's right. Way in the back.
I'm sorry, I'm Erin Neal with ATK. It's been reported in the media that the Air Force Executive Committee recently made a decision that the next ORS mission will be SSA focused. Can you speak about what capabilities you hope that will bring to your compilation?
Yes. Well, actually, if you're talking about ORS 5, yes, that will be it'll be an SSA mission, and actually, it's going to be a risk reduction effort for the SBSS follow-on program. So that's that. Right now, we're still in development of that particular mission, and they're still working towards it. But the intent is to risk reduce some of the technologies and concepts of operations we're going to have for that program, and hopefully get something up a little bit sooner to do that before the actual program of record starts in the 2016 timeframe.
this question of General Raymond, this Peter Huessy. What we often find in Washington, the ability of Congress to understand key public policy issues determines in part what budgets they support. What do you think the biggest challenges you think are with respect to getting Congress to understand your mission and your role with respect to what you need in the budget?
Well, I think events like this help us tell our story. I think sometimes maybe we don't do as good a job telling what it is that we do. And when we do tell our story, I think we get a lot of folks that come up afterwards and say, "Boy, I didn't realize that." So I think there's a need to be able to tell our story. I'm proud of what we do. I'm very proud of the work that our operators do. I have been throughout my career. I've been deployed as the Der Space 4. Now Colonel Endicott was deployed with me, and I'll tell you, I relied very heavily on the JSpOC in that role to provide information and space capabilities forward to the fight. And I thought the JSpOC delivered every time I needed something. I have been stationed in Japan, and I was stationed there during the 3rd of March of 2011 when the great earthquake occurred and reached back for capability as well, and they deliver every time. So I think we have to tell our story. I think it's an important story. I think I've been remiss at this as well. I used the 3 C's, and I think we need to bring that to life a little bit more and say, here's really what this means, and talk about it.
Good morning, Doug Young with Northrop. Just got a question that we hear a lot about in the broader warfighter community about the concept of a day without space. Kind of what's the sort of policy or viewpoint on that comment when it comes up that you can share here?
It'd be a bad day. Absolutely. It'd be a really bad day. In fact, I got to speak at another event with Bob Butterworth a few years ago. And I know there's been other folks in the room here that have deployed to theater. And when I came back from that deployment, a lot of people asked me, what was the one thing that that you got out of that experience? What's the one thing the warfighter really needs? Is it GPS or what? So that's not what I walked away from when I came back out of that. That's not GPS is important, comm is important, space weather is important. It was just how space capabilities were infused in everything that we do as a military. I will tell you, on the nation side of that as well, it's infused in everything that we do in our way of life. And a day without space would be a bad day. It'd be a really bad day. Yes. Sure. You get the pick. You've been delegated that task. Okay. You got
Dan
it.
Dan Deans with Millennium Engineering and Integration.
Yes.
Somebody mentioned ORS earlier, and you talked about the Wallops launch with 28 or 30 payloads or whatever. It seems to me that given, I call that commoditization of space. It seems to me like, shorter development times, many more payloads, a lot more of them possibly going up. How does that change your operational philosophy and add to your overall need to bring technology into this? Have you guys, spent a lot of time planning for how ORS might change, space, so to speak?
Yes, I'll take this one, I guess. Obviously, what we want to do is reduce the cycle times, and what within SY, just so you're aware, ORS is a separate program office from the Space Superiority Directorate. But ORS has some unique things unique capabilities they have that allow them to respond in a much more rapid fashion. If we would like to be able to leverage some of the authorities they have to execute things faster if possible, but obviously we still have to adhere to the DoD 5000. All I can say is that as we look at the commoditization space, and this gets back to the whole thing with JMS, what we'd like to do, there's a lot of stuff that's out there that we'd like to be able to leverage, whether it's in the commercial world or whether it's with what other countries are doing, and we have to work through some of the data sharing arrangements to make that work. And we're working through some of this right now, but it'll probably take some time for us to do that. But there's a lot of things, both satellites in space and also sensors on the ground, that are out there. Well, there's some examples I'll just make you aware of that are going on. The Air Force Academy is running a bunch of telescopes at other universities. I can't remember what this Falcon something program that we'd like to be able to maybe potentially leverage that if we can assess that the data is really working really well. We're looking at there's a concept of operations, and probably General Raymond or Colonel Wagner can talk more about it, but this combined space operations center concept, the CSPO, to bring in data from other countries and how we can get different arrangements there. And I don't know if I'm really answering the question, but as far as there's a lot of information out there we currently are not using, and we're going to try and do it as much as we can. But when the gentleman here asked the question about what's it take to integrate it, there's two pieces of it. One is on the JSpOC side, we have to be able to ingest the data in a form that's usable to us. But there's a second piece, and that's we have to modify the system producing the data in a form that we can do as well, and that takes money. We have budget. The program I talked about was the Net-Centric Services and Data Sources program. That's one of the programs where we're trying to take individual sensors and be able to export that data in a form that can be ingested. But we have a limited pot of money, and we have to prioritize it. Basically, commoditization of space, yes, we want to use everything out there. It's just a matter of priorities and what funding we have available to go do it. If I didn't answer your question, I apologize. Okay.
Ron Olson from Titan Aerospace. I'm wondering what kind of impact is Microsoft's 100,000 balloons, high-altitude balloons, and Zuckerberg's proposal for 11,000, I think, high-altitude drones impact going to have on what you guys do in terms of...
See if I could, finally an ops question, thank you. We're looking at, if you look at about 225 kilometers, about 100 kilometers and above, that's kind of what we're tracking. Lower Earth, below 100,000, kind of 100,000, even 100,000 feet. I don't think it'll have a huge impact on what we're doing. But, we look at these chipsats, as a matter of fact. Where's the chipsat still? So those things, if you look at the analysis on those, even at 225 kilometers, where these things are going to come in, they're only going to be up there, we predict, and NASA predicts as well, so for about 5 days. So this is not going to be a huge factor. I mean, I'm more concerned about what's 225 and higher, if that helps. Thanks.
Yes, ma'am.
Kay Sears with Intelsat. Yes. My question, as another space operator who's increasingly reliant upon the JSpOC for information, back to the discussion about accuracy and timing, is there any part of your mission now or in the future that you believe should be shared with the industry, with commercial operators or foreign operators?
It's a very good question, and my view is there is room for sharing, and I think there's a couple different places, and we've talked, as you know, in the past. I think, and it's great to see you again. I do think there is some potential sharing opportunities in the space situational awareness business. I think there's a lot of great capabilities that are out there that we could partner and leverage together. I also think we talked about the EMI business. I do think that there's some benefits to partnership for both of us on that as well. It's more of now figuring out how to do it, and I think we'll get there. I really do. But those are two that I would say right off the top of my head would be areas where I think it's ripe for some partnerships.
Last question.
Wing Commander Darren Lovett. I work for the EA for Space. I'm on Exchange, Australian.
Great.
Sir, I agree. You guys are doing a fantastic mission, and it's important. But I noticed that the countries that are helping contribute to the network, are paying and helping support with individual systems, like hardware in countries. So the issue here has been raised, it's money. Have you thought about, unburdening some of the issues there and bringing in partners from outside to help fund the integration of those assets, so you're not trying to do it out of hide all the time.
You're going to have to, I missed the first part of your question. Can you?
Yeah, money. It's all about money.
Well, that
right. So other countries are building stuff and helping to bring in stuff, but it's really a system issue, right? The integration, the software, JMS.
Right.
So can we bring in money from external support to help you to do that?
Let me have your card when we're done. In fact, I'd button if your uniform has a button, I'd button your back pocket to make sure your wallet's still there when you leave. That's our goal with JMS. Again, it's being built with an open architecture framework. If will desire, as we talked about, integration of multiple sensors, and what we'd like to do is say, hey, here's the standard of which you get into JMS. Here's the test bed. Go do it. Figure it out, and then tell us when you're ready and bring it in and let that integration piece. So so what I'd say is we're designing the system to integrate in an easier manner, and then look to develop partnerships and share some of that burden of integration with others.
Sir, if I could step in first,
Sure.
Just as a follow-up comment, because I've had the pleasure of learning some of the vagaries of the Australian budgeting system as well as we've been going through the C-band radar. We absolutely appreciate the support from those types of things. I'll just say one challenge, though, is it's learning different budget cycles. As inflexible as we think our budget cycles are, some other countries have some other difficulties. We have a very difficult time to figure out what we actually need in a time frame. And I know for Australia, for example, you have to have everything nailed down to the smallest, minutest detail, and we sometimes have difficulty doing that. So as we want to get some of that, we have to work harder to make sure we really get our requirements down so we can have other countries contribute those budgets to it as well.
But I will tell you, I greatly appreciate the partnership that we have with Australia, and I thank you for being here this morning and for what you're doing. I think it's going to be very valuable to both of our countries going forward. So thank you.
Thank you, General Raymond. Thank you, Colonel Wagner. Thank you, Colonel Bowman.
Can I have one more minute?
Absolutely, sir.
I just want to say thank you.
Thank you, sir.
I appreciate very much the Institute. I appreciate your leadership in pulling these together.
Thank you, sir.
It's, as I said, it's important that we tell our story.
We will help you do that.
It's, I can't say it's great to be here from Vandenberg. Everybody says it's always great to come to Vandenberg from Washington, D.C., but it really is.
It's not snowing.
It really is good. It really is good to be here, and I appreciate you giving us the forum to talk about the important work that we do. So thanks, Peter.
I would also like to say thank you to Doug Berkey, who heads our institute with General Deptula, and Matthew Brazotti, who helps, and particularly Kathy Ryan, who came to me with this idea.
She hit me up in the day of my change of command. I was like in the job for 5 minutes, and I already had my first speaking engagement.
And also Mary Ellen, who is also with the Air Force, with the Mitchell Institute. And again, I want to thank my sponsors. Without you, this does not happen, and thank you all for your help. And again, thank you, Colonel Bowman, thank you, Colonel Wagner, and thank you, General Raymond. Sure. Your remarks were wonderful, and thank you. Come back next year, if you would, please. Would you all thank our speakers very much? We will see you next, I think it's May 2nd, and then our regular missile defense, nuclear deterrence, proliferation, arms control, and defense policy series starts the 29th of April. You'll be getting invites from both Eventbrite and Constant Contact. So let me know, of course, if you're going to attend those. And again, thank our speakers, thank our sponsors, and thank our attendees. Have a good day. Take care.